So if you see how the traditional system is works, how the data is getting processed in existing system, so I can say we are getting the data from the different sources, right? We'll be getting the data from the different sources. The sources can be anything. The sources can be anything, like it can be your financial institutes, it can be your financial institutes, it can be your sensor, satellite, it can be your CRM or ERP applications, it can be anything, right? So these are the sources who produces the data. These are the sources who produces the data. The data will be producing by these systems. The data will be produced by these systems. What we will do, whatever the data comes from these systems, these are called sources. These are called sources. Whatever the data they are producing, that is a raw data. Why we will call raw data? Because the data is directly coming from the sources, it's not gone through any process. The raw data may contain the duplicate records. The raw data may contain some hexadecimal kind of data. The raw data may contains which is in not in proper format, right? The raw data contains which is the necessary and unnecessary details in it, right? So the raw data contains which is required, which is not required. So then what we need to do from this data, we need the valuable information, and that valuable information, using that valuable information, what we will do, we will improve, I mean we will process the data, we will use that valuable information to improve our business, to bring the new strategies in our business. So how it will work? So what is the data? So why we need to process it? So let's look at here. I'll just show you a simple example. I'll show you the simple example. Okay, this is my channel. Okay, so let me take through my channel. This is my channel. So in this channel, I want to know the analytics of my channel, how my channel is performing, how many people are visiting my channel, how many people are getting benefited out of these videos, and is there any people are giving me a comments. So that kind of information I want to see. So what I will do, I have an application here which is called analytics. It's similar to your reporting tool, guys. It's a similar to a reporting tool, or it's a similar to a dashboard in the real time. Okay, here if we see here, if you guys see here, the watch time is this much, and the average duration is this much, and the views are this much. Okay, and likes are this much, dislikes are this much, and comments are this, and shares are this much. So here if we see here, these are the analytics. These analytics, how they are producing based on the data, the based on the people who are logged in time and they're watching my channel, or the based on the time, how much time they are watching the video, and based on that they have done some operations, likes and dislikes, and what they have done. So based on their actions, each and every action in the YouTube, the data is getting generated. So in the background, the data is getting generated. That data, they are processing that data. So if you see here, this is all, it's like your report. Okay, this is like your report. You can see here videos and what is subscribed and unsubscribed, all devices, and this original language and translated, and last 28 days, last 1 year, last 2 years. You can select any of the categories, or any of the way you want to see the report, right? So you want to see only watch report, real time, and watch time. So when you select this, what's happening, whatever the data they already available in the system, the data is getting processed, and the data is getting showing you in the form of a report. How it is happening? If it is, is that happen easily when you have a raw data? No, it is not happen with the raw data, because the raw data may have a duplicates, the raw data may not be in a proper format, the raw data may, which contains the necessary and unnecessary details. So to generate this report, I need only few parameters. I don't need all the parameters. But if you take the raw data, the raw data contains so many parameters which is I don't require for produce a report. That type of data we will call raw data. We will call raw data, a data which is came directly from the source without, it's not gone through any process, which contains the necessary details and unnecessary details. That data we'll call as a raw data. So this raw data I want to process. What we will do, we will take through some process. The process we'll call as a ETL. We just heard so many people are working on ETL. What is the ETL? The ETL is a process. It will extract, it will extract the valuable information by applying some transformations, and we will load the data after extracting the valuable information by doing so many transformations. And the data, what we will do, we will load into, we will load into a machine, we will load into a machine where the data will be in the form of tables. The data will be in the form of tables. Why data has to be in the form of tables? Very simple. It is easy to access. It is easy to generate queries, generate reports, right? Before loading the data, the L transfer load. Load. Before loading the data, we will apply some normalization forms. And once the data is available in our data warehouse system, the storage, whatever the storage will call, we will call data warehouse system. And there is something called database as well. So we need to understand what is the difference between the database and data warehouse system. So database is mainly where we will be doing online transaction process. You will be putting the data, you will be modifying the data, you will be updating the data. This kind of operations you will be doing a real-time transactions with your database. And data warehouse system is a system to OLAP. What the system will do, this data we will use for analyzing. We will use this data for only analyze, right? So we will talk more details what is the OLAP and OLTP later point of time. If anyone want to know about it, so you guys can get some knowledge on this. There are some videos also I have been made in difference between the OLAP and OLTP. We can have a look on them. So then once the data is available in our data warehouse system, and we will be having a processing system or producing a reporting system where an application will be running on it, to generate a report. A processing system I can call it is. This is the storage and this is the processing system. Okay, so when I want to generate a report, what I will do, I'll select the categories as I shown in the before diagram, before the YouTube analytics. Whatever the analytics I want to see, last 28 days or last 1 month or last 30 days, I will just select those categories or those parameters. What are the parameters I want to see? So I will select those parameters and I'll apply. As soon as I click on apply, what it will do, it will generate some query at the background. It will generate a query at the background. So what this query will do, this query is require some data. The data will be start downloading from your database, and the logic will be applied on the data. The logic will be applied on the data. So after applying the data, the system will produce the reports. The system will produce the reports. These reports, it can be bar chart, pie chart. It's the what type of report, it's really no matter, because we need the values, we need the figures, we need that numbers, right? So that reports will be generated. So the report will be making use by your business analysts, the business clients, data warehouse administrators, and the people who are want to see understand what is the report it is, who will take the business decisions. They will be looking at the reports, they will be making use of the reports. So what we have done, we have taken the data from the source, we have gone through some ETL process, then we loaded into data warehouse system or database system. Data warehouse system ideally it is for the only analytics, and from there we move to the processing system to produce the reports. Good. It looks very simple. It looks very simple. This is how a traditional system works. This is how the traditional system works. Then what is the problem? What is the problem? 1 second guys, I think someone is facing some problem here. Ganesh, could you please re-log in and try? Okay. So this is how the traditional system is. So it looks very simple and it's working perfectly. So what is the problem here? Why we need to move to some other system when I have already an existing system? Why? What is the reason behind it? This system, this approach has been designed a decades before. So when the system is designed, that this design or they have created this design when a decades before, when they have a less amount of the data, less amount of the data. So very simple, guys. So I have seen the floppy disk. So I don't know how many of you have seen the floppy disk. And what is the capacity of the floppy disk those days? 1.47 MB. So those days we used to manage the data with 1.47 MB. Still there were very less devices who carries the small amount of the data in early days, right? So when they designed this approach, they were having very less amount of the data, keeping in mind that they have designed this approach. So this works very well with the less amount of the data, and to produce the report in a given time. Let's say here, let's say here, I have loaded a huge amount of the data. I have loaded a huge amount of the data in this, and I want to find. Let's take this is an Amazon data. I want to find how many new registrations, how many people have purchased mobile sales, books, home appliance. So I want to see category wise how many are purchased what. I want to see those information. So what will happen? I will load this data. The data will go through a ETL process, and the data will be processed through. I mean, it will be loaded into here. So once the data is loaded into here, let's assume that it's a 50 GB. As soon as I select the report, the data has to be processed. So that to process this data, the data has to travel towards your process engine. And let's assume that it may take in 2 minutes of time to load the data. And let's assume that to process the data again, it takes for 2 minutes of data, or you can take less than that as well. We have a very good bandwidth machines where we can transfer 10 GB per second. Okay, so total 4 minutes of time it is taking to load a report. So it means to load this much of huge amount of the data, my process engine should be very capable enough to handle that much of system. It means I should have a better processor and to generate the report in given point of time. So to process this data to produce a report, it is taking 4 minutes of time. Let's look at here. If I'm selecting here some categories, last 30 days or last 28 days, first 28 days. So I'm selecting some categories here. Based on my category selection, it is start producing the report in a fraction of seconds. If let's assume that if it is taking 4 minutes of time to produce a report or 4 minutes of time to process the data and see the report, do we wait in the system? I mean, do we sit in the front of the client, that application? No, we will not, because we want to process quickly and we want to see the report very quickly. So if you guys see, I have seen something like I have seen most of the client where I work for the different clients, they want the report in 5 seconds. This is the benchmark. They want the report in 5 seconds. If it is taking more than that, they will say that no, you should try to reduce to 5 seconds. I don't want to wait to it will keep rotating to load the data. I don't want to see that load. The data has to, as soon as I select the different parameters, my report has to be appear like that. Okay, so this is the benchmark. To achieve this benchmark, we started facing some problem with this. Why we started facing the problems? What are the problems we started facing? Let's look at here. So as soon as the data is increased, very simple, guys. If you take the whole data whatever is there in the world now, if it is 100 percentage, I can tell that it's last 90% 95% of the data has been generated last 4 to 5 years, hardly 6 years. So rest of the only 5% of the data was early old data, but last few years the data is increased drastically and the huge amount of the data has been produced. So to process that huge amount of the data, so this problem has started showing some limitations. I'm not telling that this approach cannot be processed. It will be processed that, but with some limitations. What is those limitations? We'll go ahead and see now. So as soon as the data is grown, what is the problem? What are the problem has? So these ETL tools are not open sources. The very first thing. We need to go with the better ETL tools. We need to go with a huge number of more licenses to process this data, where the cost is involved. Where the very first one is cost is involved. And even I have no, gone through, I mean, I have purchased the ETL tools by paying more amount of money. Like, I have taken so many things, and whatever the existing storage system I was having, that won't be enough to store the data, because my data is grown. So as soon as my data is grown, I need to replace my existing system. The existing system is, I can say it's RDBMS. So the RDBMS is always scale up approach. It is not scale out. I need to go with a very bigger machines, but bigger machine. I need to replace with a very big machine. So where I need to involve, I need to go with a very dedicated hardware for this. I need to spend some more amount of money in this. So again, the cost is involved. Fine. So cost, I have invested some amount of money. Let's see the what else the problems we can see here. The data is available here. The data is started processing here. Time. So to download data, it is taking some amount of time, and to process the data is taking some amount of time. So what is happening here? The data is traveling from your storage to process engine to the data is traveling from your storage to process engine to process the data. This is causing time. This taking more time to process. The second cause is time. I will tell what is the time here. Okay, why it is taking more time, I'll explain detailedly now. Let's look at here why it is taking. The first parameter, the data has to travel from one hard disk to another hard disk coming through a network. Okay, the data has to travel from the storage to process. So data is traveling. This is called non-data locality, or you can say it is a code locality. What is the code locality? Wherever your code is there, your data is traveling to the code. Wherever data is there, your data is traveling to code. So here my logic will be here. My data is traveling, which is takes so much of time. The transferring the data itself will take so much of time, right? So instead of that, so I have written a very big logic. I have written very big logic, or I have written so much of code. So many files are there. Even if I write very big project, hardly the project size will be in 100 MBs. My code size, my logic size, it will be hardly in 100 MBs. Instead of downloading the data to process towards a process, I will upload my logic to where the data resides. Okay, then my data will be processed wherever the data is there, and it produce the results. I'll be collecting those results. So instead of downloading 50 GB data, I will upload 100 MB my logic towards my data, or where my data resides, and there I will process, then I will collect the results. So it will reduce so much of time. It will reduce this 2 minutes of time. This is called data locality. In existing system, we do not have data locality. Data locality means wherever the data is there, you go and process. We will talk more about what is the data locality, how it will work. Even I'll show you an example as well in the top of it. So if you're not able to understand this, please ignore and just continue, and I will talk more about it. I'll show you in a real-time example also what is the data locality, because the data locality is the main feature of Hadoop or any distributed systems now. Okay, so I got some question from the Damodar. Damodar, it is a Hadoop and Spark session. Damodar, it is a Hadoop and Spark session. So there are most of the guys who don't know the who don't know Hadoop as well. So it is like we are going to take them through Hadoop. Then once they understand what is the storage and what is the process, then I will take through them languages like a Java, Scala. Then I will take them through Spark. Okay, so this course contains, so I supposed to talk about this before starting on a session itself. So I was waiting to everyone join to talk about this. Okay, uh, so I will talk what are the things we are going to cover in this the coming classes and the sessions. I already have shared some content to each and every person. So we will talk what I'm going to cover as part of this coming classes and the sessions, these morning sessions. So I will talk in the end of this session. Okay, so it will be Hadoop plus Spark. So for to put it in a very simple way, it is Hadoop plus Spark. Okay, okay, and also guys, I'll really love to hear from you guys. Don't wait to finish my things. So you whenever the problem raised or whenever the question raised, please go ahead and unmute and talk. Okay, I don't have any problem. Okay, please don't wait till I finish something. So because if you wait, so what will happen, sometimes you may lose the concentration, or you may forget that question. So I want you guys to, as soon as the question raised, go ahead and ask me. I don't have any problem with it. Okay, so this is another limitation. We do not have a data localization in an existing system. That's another problem. It's causing more time consuming. And also, the whatever the existing system, it is not fully distributed. It's not fully distributed. Some people are there, they will say that no, we are using a data warehouse system, or we are using the database system clustering. We are using multiple MySQL instances and different machines, and we are processing the data. I will show that what is the problems associated with that approach, and that MySQL instances are collecting keeping a cluster using MySQL instances or Oracle instances. It will take some limitations are there, and it is a very difficult to manage, and we will be keep seeing the downtimes for that. I will tell what is that. Okay, so we do not have a distributed, no distributed. What is the problem if I don't have a distribution? Because if you don't have a distribution, this is a sequential process. This is a sequential process. If you see here, the data is getting processed sequentially. The data is getting processed sequentially, no parallel process. We don't have a parallel process. No parallel process. If you don't have a parallel process, ultimately it will take so much of time, right? To get into the parallel process, the data has to be there in multiple places, the distributed manner. We will talk about each and every feature of it. And let's assume that I'm processing the data. While processing, this machine is gone down. This machine is gone down. Is my job will fail or success? Job will fail. Why it will fail? I do not have any other mechanism saying that if this machine is not available, you go and connect to this machine, process the data. That mechanism is not there in existing system. That mechanism is not there in existing system. That is called, we do not have auto fault tolerant. Auto fault tolerant. We do not have auto fault tolerant. So, and also I suppose if this machine is gone down, I'll be losing the data. But we may say that, sir, I am taking the backup. No, I have a backup mission where I'm taking the backup. Even this backup is periodical, hourly basis, or some basis, right? So let's assume that once the data is available in this machine, the original machine, then only will take the backup. But it is not automatic backup. I'll tell what is automatic backup. You will easily understand by explaining the next feature. There is no automatic backup. That's called replication. That's called replication. So these are the limitations are associated with an existing system. These are the limitations are associated with an existing system. Why these limitations are? Who causes this problem? So it was working fine. This approach was working fine, absolutely fine before. Then why it started showing some problems? Because the data is grown. The data is grown. When the data was less, it was working fine. The data was less, it was working fine. When the data is grown, it is started showing some limitations. Those limitations are cost, time, your no data localization, the data is not distributed. So mainly cost and time, I can say. Cost and time. Why time is time consuming process? Because of these other processes. I do not have a no, automatic backup is not there here. I do not have automatic backup here, right? So these are the limitations are associated with an existing system. An existing system. So who is causing this problem? Before it was working fine. Who is causing the problem? Who is causing the problem? Guys, could you please unmute and talk? Who is causing the problem? Oh, everyone is so silent. Guys, could you please go ahead and
It is
talk?
because of right.
It is because of
I think it is because of the data fused.
huge data. It is because of the huge
Right.
data has been generated, the huge data, right? So let's try to understand little about the what is the data, what is the big data.
Mm.
What is the big data? What is the big data?
Amount of data.
Huge amount of
Large
the
amount
data.
of data.
Large amount of the data. How much large it is? Is there any constraint? How much large?
Maybe a petabyte.
So
No limit on that.
petabytes of data. Okay. Yeah, I'm coming to that point, Anil. So someone is telling petabytes of data. So if I have a data in 100 in MBs, let's say I have 100 MB data. Can I say this 100 MB data is a big data? Can I say the 100 MB is the big data?
No, it's very less in size.
So why? Why can't I say 100 MB is a big data? Why can't I say
So 100 MB is very limit and it is easy to process.
yes, it is easy to process using an existing system. But if I ask you to send me 100 MB file through email, can you able to process? Can you able to send me? Forget about I'll keep in drive, I'll share the drive. So don't tell me that answer. So if I ask you to send this 100 MB file through an email application, it can be your Yahoo, it can be Gmail or anything. Can we able to process? Can we able to send? No, because
No,
for that
no.
application, this 100 MB is a big data. For that application, this 100 MB is a big data. So when we say big data, it has some classification and characteristics. We'll talk about them. The data which is not able to process using current system, that data will call as a big data. A data which cannot able to process or manage and store efficiently using current system, that data is a big data. It can be 100 MB, it can be 100 GB, it can be 1 TB or petabytes of the data. So based on the current system, with respect to whom we are talking, that system is not able to process or store and process the huge amount of the data efficiently. Efficiently means I want to generate the report in 5 seconds. I'm not able to generate the reports in 5 seconds using current system. That data is a big data. I may be able to process it. I'm able to store the data. I'm able to process the data, but it's not efficient. I'm taking so much of time to process. That data we will call as a big data. That data will call as a big data. So this data has some characteristics and classifications. This data has a classifications. The
Sir,
classification
very
is,
good.
yeah, go ahead, Ram.
Actually, big data means that is not only size and
Coming to
what
that
is
point.
that?
Yeah, I'm coming to that
Yeah,
point.
structure.
I'm coming
Okay,
to that point,
okay,
Ramesh.
sir.
Actually, that's why I brought the classification and characteristics.
Sure, sure, sir. Thank you.
I'm going to explain that. Yeah.
Mm.
Yeah. Okay. So as we say that big data, it has some classification characteristics, not only the size, as he said, correct. So I'm going to bring that now. So the data has been classified into some three categories, like a structured data, semi-structured data, and unstructured data. And not only these three, we will be talk more about this because we are getting uh, getting late for I mean we are running out of the time. I will talk each and every point very detailedly, and even I have already talked about this in some of the videos. We can I can explain in the each and every point detailedly, but for time being I'm just going very high level. Structures data means the when you look at the data, it has a proper format and it has been delimited by the single delimiter, and from wherever I collect the data, from whatever the resource I collect the data looks similar and the data will have the same delimiter. That data is called as a structured data, that will be having the proper format, and like your tables. So what is the delimiter here? Columns, your CSV files, your tab separated files, your XLS files, not XML, XLS files, right? These are some examples of structured data. We will talk more about it in a, no, and the dedicated sessions are there for this. We will talk about them. And semi-structured data, we will talk about the semi-structured data. When I talk about this unstructured data, the pure unstructured data, the best example for unstructured data is images, audio, and video. These are the best example for unstructured data. Rest of the data, what are the falls under, not fall under these two categories, the data is a semi-structured data. It can be your text data, it can be your emails, that can be your log files, that can be your XML, that can be your JSON, that can be any other format of the data. That can be any other format of the data. We will talk more about this classification, guys, because we have a dedicated session for them. So we will talk more about that. I just want to introduce a Hadoop. So that's the main motto of this thing. These are all the background. So we're trying to understand. And the classification, coming to characteristics, the data should have some. When I talk the big data, it will have some characteristics. The characteristics are, some people will say 3V. Actually, someone says 10V, but I found 6Vs. So I will explain what is the 6Vs and not the 10Vs. So that 6Vs are volume, velocity, variety. The variety, just now we talked, the structure, semi-structure, unstructured, and variability. Keep changing variability. And there is something called veracity. There is something called veracity. How good the data is, how trustworthy the data is, right? The final one and my favorite one is value. 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 Without value, there is no point to process. If we don't have any value, so in the today morning 5:30, why we join? Why we are attending the session? There should be some value. So to attending the session, we'll gain some knowledge. That knowledge will help to grow in our career. That is a value, right? So we will talk on each and every point. The volume means how much data you are going processing and how much data is getting produced, how fast the data is getting produced, the whatever the data we're processing, how fast the data is getting generated. Varieties of the data, it can be structured data, semi-structured data, unstructured data, and variable data. Today my source is giving me a structured data. All of a sudden the application new source has been introduced, and then the source has started giving me a semi-structured kind of data. So my cluster or my process should be capable to handle that. That is a variability, like our variables in our other languages. Veracity, how good the data is, how trustworthy the data is. And the value is, so whatever the data we are processing, see here as I shown before in this analytics, if I'm not getting any benefit out of this by seeing this report, there is no point to process the huge amount of the data, right? So that's the reason the value is most important thing. That's the reason the value is most important things. The classification and the characteristics we will talk in each and everything in a detail. And for the volume, I will be showing in each what is the example for the volume, how volume, and so Facebook is producing how much data, your YouTube is producing how much data. I'll be giving you each and every example for each and every point. So let's get into Hadoop. Let's get into Hadoop. So we have seen who's causing the problem, and we've seen what is the problem and how to solve it. The solution for this is Hadoop. Hadoop. Now actually we get into the Hadoop now. We are going to see what is the Hadoop now. So what is the Hadoop? What is the Hadoop? Hadoop is an open source Java based framework which is meant for store huge amount of the data and process the huge amount of the data efficiently. What is Hadoop? Hadoop is a Java based open source framework which will store huge amount of the data and which will process that huge amount of the data efficiently. How it will process, how it will store. So as I said before, Hadoop come up with two beautiful components. What are they? HDFS, MapReduce. HDFS and MapReduce. What is the HDFS? HDFS is Hadoop distributed file system. What is MapReduce? It's a map and reduce. Two operators, map operator, reduce operator. We will talk about them later. First, try to understand this HDFS. Okay. So let's take a word by word from this HDFS. System, file system. What is a file system? What is a file system, guys? What is a file system? Guys, you guys has been muted. Okay, could you please unmute and talk?
Any system that stores the files.
Any system that shows the file. Okay, anyone else?
That's where we store data in an organized way.
Yes. Your file system keeps track of how the data is stored and how the files are stored in our hard disk, and it will be keep track of those references in our file system. This file system will be made used by your operating system, right? So it will maintain the tables in that internally. So we're not going to see very detail about that. So it is your file system tells that how you organize, how you manage, or how you store the files in your hard disk, right? So this file system will be making use by your operating system. The file system is a virtual layer, which is not a physical, which is a logical. Okay, so what are the file systems? I can say there are different kind of file systems. I can say FAT file system, I can say new NTFS file system, new technology file system from Microsoft, and I can say we have ext, ext4. There are different kind of file formats of the file systems are available. So already have a file system, then why I need a special kind of file system? The point number one. And the next word is distributed file system. What is the distributed file system? What is the distributed file system? Distributed file system is a data will be distributed across the multiple machines. The data is distributed across the multiple machines. The data is distributed across the multiple machines, and all machines will be connected through a network. All the machines will be connected through a network. They'll start share the data. The data will be distributed across the multiple machines here. The data is, it's like your shared drives in our organizations. We'll be seeing that students, employees, projects, softwares. So what I will do, this machine will store only employee data or student data, only projects data, only the software related data. And whenever try to access that shared drive or a common location, a shared location, for me, here it will shows that employees, employee related data, student related data, project related data, software related data. It means for the client, it looks like a single hard disk. Even though the data has been distributed across the multiple machines, as soon as you log into the shared drive, for you it looks like a single hard disk. It looks like a single computer maintaining all the data, right? It means the data has been distributed and the data has been shared across the network. It's called network file system, NFS. As soon as the client log into that, and as soon as the client is looking into the network file system, he is able to see, it looks like him, all the data is available in the single location. He feels like it is a single hard disk. Actually, it is not a single hard disk. The data is distributed across the multiple machines, but the data has been shared into a single location. So if you have authentication, you can go ahead and access it. Already have a NFS. Already network file system is there. We are already seeing from so many years. Then why we need to go with the Hadoop file system? What is the problems with an existing system? First, try to understand, if you don't have a distributed file system, forget about Hadoop. If you don't have a distributed file system, what I need to do? If I want to access employee, a student related data, I need to log into these machines manually. Then if I want to get the data from the student, I need to log into manually. If I want to process the data, I log into manually. So every time I need to log in separately into those machines to access the data or to process the data, right? Every time I need to make a new request. If it is a distributed, all the data will be in a single location. I no need to talk to multiple times with the different machines. Here 4 machines, 4 times your logging is very easy. If we say 100 machines, right? So if it is a distributed, it's easy to connect a location where I can, if I want to process employee data, I'll process employee data. If I want to process student data, I'll process student data. If I want to process something else, I'll process, but I should have access for that. Okay, but here what is the limitations? Anyway, I have a distributed file system, right? Then why I need to go for Hadoop file system? Here, if I want to process employee data, I need to process in this machine only. It is not distributed manner. While processing it, if I lost this machine, it's a sequential process and single point of failure. There is no backup for this, right? So I can here again it follows the normal file system only. So I have some limitations with the distributed network file system. I can say network file system or distributed file system, an existing distributed file system. So while processing this, if this machine goes down, my job will fail and I lost the data. And it is a sequential process, one after one only I can process. I want to process employee student. Then once I finish with employee, I can go ahead to process this. Once I finish this, I can go and process this. Once I finish, I can go and process this. It is a sequential process. So to avoid this limitation, there is something called Hadoop file system. How Hadoop file system works? How Hadoop file system works? So let's have how Hadoop file system works. So Hadoop file system works. The Hadoop file system works following two type of machines. It follows an architecture called master-slave architecture. Master-slave architecture. To process the data in the Hadoop HDFS Hadoop file system, we follow an architecture that is called master-slave architecture. The master-slave architecture need two type of machines. One is master type machine. Other one is slave type machines. The master type machines will call name node. I'll tell why we'll call name node. Why can't we give different name for that? I will explain the very detailedly. So we will have two type of machines. These machines are called data nodes. They're connected to this machine. They connected it. And this machine is called name node. Why we'll call name node? Why only call name node? Why can't we give as a master? Why then they have named it as a name node? So I'll explain each and everything, why they call name node and why they call data node. So here your HDFS follows master slave architecture, where your master is the name node, where your slave is the data nodes. It is a collection of computers. It is connect all the small computers together and work as a single computer. That is the concept of HDFS. Connect your all small machines and work as single machine. That is called HDFS. Okay. Here, all these slave machines will be keep reporting to that, saying that every 3 seconds they will be saying we have connected to you, and we are they will be keep reporting. That's called heartbeat. and the heartbeat will go through RPC protocol. So I'll show you each and everything here. So it's not like a blindly you'll go and talk to him, right? They need some protocol. The protocol is RPC protocol. Every 3 seconds they'll go and report to a master saying that I am alive, and your actual data will store in the data nodes. Actual data will store in the data nodes. How the data will store, how it is different from the normal file system, we are going to see it now. So I'll be taking another 10 minutes of your time, guys, so please bear with me. If anything is need to cover, we can continue in the tomorrow's class, not a problem. So I request you to please spend wait for 10 or 15 more minutes, then let me finish. We'll finish this part, then we will continue. Nothing. Okay, so I'm going to show you how the data will write into HDFS, then based on that we will be talking. So now this is my cluster where I have a master and where I have a data nodes. The nodes are connected to the master, where my nodes are connected to the master. So how it is different from other file system? It is different from other file system. I'll show you here. So before this, let's talk about how the data will store in the local file system. How the data will store in the local file system. First we need to understand how the data will store in the file system, distributed file system or normal file system without Hadoop. I'm talking about how the data will load into file system. This is called local file system. Let me talk about this. It's a local file system because it's local to your operating system. It is local to your operating system. So let's say I have there is a book called Hadoop.pdf. I want to load this book into your HDFS or no, local file system, not HDFS, normal file system. What will happen? Internally, while I'm writing this data into my hard disk, it will break into small blocks. The data will not store directly as our PDF file. Internally, in the hard disk, the data will store in the small blocks. So in the normal file system, the block size is 4 KB or 8 KB. Okay, in the normal file system, the block sizes are 4 KB or 8 KB. What is the block? A block is a piece of data which will store in between the sectors in the hard disk. What is the sectors? So if you see your hard disk, your hard disk will contain a collection of tracks and sectors. Please bear with me, guys. I'm very poor in the drawings. You can see these are tracks and we'll be having a sectors. Tracks and we'll be having a sectors, right? So here, whatever the data is stored in between one sector to another sector, whatever the data is stored from one sector to another sector, that is called a block. That's called a block. Sector, track. Okay, that's the block. So in the normal file system, the hard disk in the normal file system, it acts as small block. Okay, so while reading also, it will read in the block wise. Even though you are seeing as a single PDF file, it is reading from the hard disk block by block. It is not reading whole file system at a time, whole PDF at a time. It is reading by block. While it is storing also, it will load as a block by block. Then when you say HDFS, when you install Hadoop on top of this file system, which is a virtual layer, so here it also follows the same block mechanism. Everyone follows the same. Any file system follows the same mechanism. But here the block size is a bigger block. The block size is here 64 MB or 128 MB based on the Hadoop version you are using, HDFS version you are using. If you are using Hadoop 1 version, the block size is 64 MB. If you are using Hadoop 2 version, it is using 128 MB is the block. And so okay, that's fine with the blocks. Okay, in the local file system also have a blocks, in HDFS also have a block. Suppose in the local file system you are copying a Hadoop file system, let's say in this distributed manner. So I have loaded Hadoop file here, so Hadoop PDF file. So will I have duplicates? Will I have a duplicates as soon as I load the file into normal file system? Will I have a duplicates? It means duplicate copies in different locations? No, I'll not be having a duplicate copies until unless I have take a backup manually, right? So there is no automatic backup in your local file system. If you are storing into one machine, let's say I'm storing into this machine, the data will be there in this machine only. It will not be copied. The same copy will not be copied some other location for the backup purpose. No. So that is one of the limitation of your local file system. But when it comes to Hadoop, as soon as you are loading into one copy, as soon as you are loading the data into HDFS, it will maintain three replicas. Three replicas. Why three replica? Why can't it be two? Why can't it be four? We will talk about it. Why is the block is a bigger? Why can't it be lesser block? Why the block size is bigger? We will also talk about that. That's the most important thing we need to understand. Otherwise, there is no point no understanding Hadoop. So learning only concepts or learning only the syntaxes, it not help you to understand the more. I say to better understanding. I recommend you to understand the internals of each and everything. Why 64 MB block or why 128 MB block? Why three copies? Why Hadoop? Okay, why master slave architecture? Why they call as a name node? Why they're calling as a data node? So we have to understand the internals of it. So let's simply don't understand like name node there is a one machine, data node there is a one machine, data node will store the data, name node will just manage. So that will not help. That will make you understand, but no, that will not give you a whole idea, and that will not satisfy you. Why it is storing the data? Why I need to call it as a name node? Why it is call as a master? That internal things we need to understand. So the difference is here compared to local file system and HDFS. Here by default it will maintain three copies and the block size is very bigger block. If it is a very big block, the advantage is you can easily seek a very big block. Here as soon as you're seeking a small file, small block 4 KB. Suppose my Hadoop file system is 1 MB. How many seeks I need in the local file system? So many seeks. If it is Hadoop, only one seek. Just a seek and get it and transfer the data. We will talk about that. There is something called data transfer and there is something called seek time. These are the two important things to understand. Seek time, data transfer rate. If you understand these two things, you understand why the Hadoop come up with a bigger block. Why Hadoop come up with a bigger block? For to understand why three replicas, we need to understand something called rack awareness and replication factor. Rack awareness, I will talk about the rack awareness later. Okay. If you understand these 3 points, you will be very much clear about these 2 points. Okay, let's go back to Hadoop. Okay, let's go back to this thing, name node and data node. Here, let's say here I want to store a data into my HDFS. I'll be taking another 5 minutes, guys. If anything needs to be discussed, we'll discuss in the next class. So I'll be taking only 5 minutes of your time. I know that I have taken much time for the explaining the background, but don't worry, we will be continuing tomorrow. Tomorrow we'll be having more detail about Hadoop, more detail about HDFS only. Okay, that's where we'll show the without understanding the background why we need Hadoop, there is no point to go with what is a Hadoop and all. That's the reason I have shown the background and limitations. Here, this is my Amazon data. Just 5 minutes, guys. Amazon data. The file size is, let's assume that 1 GB data. The file size is 1 GB. Now I want to put this data into HDFS and I want to process this data. What will happen? To store into HDFS this data, I'll be having a client. Client is nothing but from where you are executing your commands, or from where you are executing your copy command or whatever it is. I will talk more about that later. Okay, there is a client. So as soon as I have written the command to store this data into HDFS cluster, Hadoop cluster, first the client will look at the file, and it will find the size of the file. Then it will break the file into blocks. It will break the file into blocks because the data will store in HDFS in the form of blocks only, right? Any file system, the data will store in the form of blocks. Block is a chunk of data or piece of data. The data will be loaded into blocks. Now your client will take the first block. Your client will take the first block and will go to the name node. Name node is nothing but your master, saying that my block size is a bigger block, which is 64 MB block. I want to copy into 3 places. I want to copy into 3 places. Give me 3 places where I want to store. Now your name node is a manager, like our manager. The new client came with a new task. How our manager will identify the resources? The same way. What your manager will do? Okay, so this guy, he's efficient working on the Java. This guy, he's efficient working in the background. So this guy is working efficient in the testing. So he will be having that information. Your manager will have all the metadata information about, right? So as soon as the client comes for the new storage request, what the name node will do, he will look into the machines and he will try to understand which are the things I need to refer or which are the machines I need to give. That is called block placement policy. That is called block placement policy. That's called block placement policy. Following that algorithm, our name node will identify 3 machines. Why 3 machines? I want the 3 copies. He will respond with 3 machines. 1, 3, 5. 3 different machines. He will respond with the 3 different machines in a sorting order. Sorting order based on what? The network distance from the client. The network distance from the client. So mission 1 is near to the client. Yes, give that. 3 is near to nearest one. Give. Next nearest one is 5. So that way it will give the nearest missions. It's not always 1, 3, 5. It can be any missions. It can be 1, 2, 3 also. It can be 1, 2 also. So that's based on the algorithm. So we will talk more about the algorithm, how it will work. So now as soon as your client got the request, response from the name node, 1 is the one IP address, 3 is another IP address, 5 is another IP address. Your client will connect to the machine 1. Client will connect to the machine 1. It will create a pipeline, data pipeline, and he will start transfer this data. He will start transfer the block 1 data. So block 1 is a very big block, right? He cannot transfer that data. He will make it a small packets and he will transfer. And also he will tell to the machine 1, you connect to the machine 3 because we need to transfer 3 copies. And mission 3 will be connecting to this machine. So the data, if you observe here, this is which I'm going to show you is the metadata of the data. So Amazon data has been divided into block 1, block 2 and so on, block 8 or 9. Now the block 1 is successfully stored in mission 1, mission 2, mission 3 or mission 3, mission 5, whatever it is. And block 2 is stored in 1, 2, 4 and so on. So once it is complete with all your information, the final metadata will be like this in your name node. This will manage by you, your name node, your master. This will manage by your master. Now the data will be stored across the multiple machines. If you observe one thing here, the whole file is not stored in a single machine. The whole Amazon file is not stored in a single machine. That has been broken into pieces, and each piece has been stored into different machines. Piece 1 is there, machine 1. Piece 2 is there, mission 2. Piece 3 is there, the other mission, and so on. So now the data has been distributed into multiple machines. While processing, I can easily process parallelly. One copy will be processed here, 2 will be processed in this machine, block 3 will be processed in other machines, 4th machines, and so on. Parallelly, I can process it. So when I'm processing parallelly, my less time, I'm consuming less time. And the data, wherever the data is there, I'm processing there only. Wherever the data is there, I'm processing there only. So I have a data locality. Less time, I have a data locality. By default duplication. If you see here, so 1 GB file has been loaded into 3 GB. You may say that we are unnecessarily wasting the space. The data is more important than your hard disk. The data is more important than the hard disk. Hard disk is very cheap. Let's very simple. If anyone lost the mobile, I used to take this example. If anyone lost a mobile, he will be most worrying about it that he lost the data, not he lost the hardware, right? So because until unless it's a very high-end dedicated, I mean I can say as iPhone kind of thing, or it's kind of a specific mobile for him. So we'll be more worrying about losing the data. Here also 1 TB hard disk I will get to 2,700 rupees. So, and also Hadoop is required. Hadoop is not required a dedicated hardware like your other approaches, like a traditional system. Your Hadoop is not required a dedicated hardware. It requires only commodity hardware, which requires a cheaper hardware. You don't need the dedicated machines. Hardware is very cheap nowadays. Hardware is now very cheap in the nowadays, right? So this is how the data will be loaded into the multiple machines, and this is how the data will be processed. Okay, so I would like to stop here, guys. So what I will do, I will continue from here only. Tomorrow how the data will store and how the data will be processed, because I'm getting late to another session now. So we will do what we will do tomorrow. We will continue on the same. I'll be showing you again the architecture. I'll be showing you how the data will load, and I'll be showing you how the data will be processed, and also we'll be discussing tomorrow about these characteristics and classifications. Okay, so I would like to I would like to tell you as part of this course we'll be talking about HDFS, MapReduce, Hive, Hoop, Spark Core, Spark Streaming, and Kafka and Kafka. Here, along with these tools, if anyone interested, I'll be showing you Scala. Scala is mandatory. The Scala will be there here. Scala and Python. Okay, Python will be there, and installation setups and everything will be there. Those are very common, so I no need to specify explicitly. And you'll be having a Flume, and you'll be having a Woozy, and here HBase also I'll cover. Pig is not that much important. If anyone is really interested, I can ask them to join in other sessions. Anyway, I'll be covering in other sessions. I'll ask them to join. And Java also will be covered if anyone is interested to know the Java. And I'll take some sessions here, few sessions, and then I'll ask them to join some other sessions. So this is about our content of the going forward, what we are going to discuss in coming classes.
Hello, Ravi.
Yeah, Saraswati.
Is it daily classes, right?
Yeah, it's a daily classes every day morning. It's a daily classes.
Okay. Okay, Ravi.
Yeah, I'm not
Ravi,
covering machine learning. Yeah, go ahead.
Ravi, this is Ashwini. Actually, we missed your introduction. Just give me.
Okay, so my introduction. My name is Veera Ravi. I have total 8 years of experience, and last three and a half years I'm working on Hadoop only. So now I'm working in the Spark. Last 1 year.
Okay. Okay.
Yeah.
Okay.
So I have
Thank you.
total, I think 9.7. I think 8.7. This year I will be completing 9 years.
Okay.
Ravi, is it 7 days classes or otherwise how it is? Is it 5
It will
days?
5 days class. 5 days class. If any
Right.
day we required, we'll sit in the Saturday Sunday.
Okay.
Okay, so please don't miss tomorrow class, because tomorrow class we will be discussing more about Hadoop. So I recommend everyone please join tomorrow's class, and you guys can make a note of my number, and if you guys want to talk to me personally or something, you guys can ping me. My number is 9986, sorry guys, 9986 755 336. The same number for WhatsApp as well as my personal number. So you guys can connect with me for content. I can send the content as well. You guys can have a look of the content, and we can talk about that. Any doubts, any personal questions? I'm keep hearing that people are saying that I am not from the programming background, I'm not from this background, that background. So we can also discuss about it. 9986755336.